Hello everyone, for First Updates Now, I'm Tyler Olds, and you're watching Behind the Bot. It's Fun's FTC show where we showcase robots, what makes them work, and some of the cool features and capabilities on them. And today I'm here with team number 15959, Central Lakes Robotics, out of Fergus Falls, Minnesota. 15959 is a third-year FTC team. Last year they won the North Dakota State Championships, and they actually have some experience prior to FTC in Best Robotics. And today I'm here with both Lexi and Thomas, and we're going to be showcasing their robot, of course, the ring path through their robot, their wobble goal. They got a couple wings on their bot as well, too. All this and more coming up on Behind the Bot.
Giving you a voice.
Making it loud our own way.
Welcome to the fun.
We would like to thank our friends at Stryker for supporting Fun so we can continue to make content for you. Stryker is a leading medical device company and is looking for those in FIRST to join their team as interns or for a great career. Come join a company that will actively support you being in FIRST at careers.stryker.com. Hey FTC teams, championships may be canceled, but FTC Reveal Night is still on, where you can create a 2-minute hype video to show off your team to the FIRST community. Last year, dozens of teams submitted their robot hype video and thousands watched live as they were showcased. The event will take place on Saturday, April 24th, and submissions are due by Sunday, April 18th. Find out more information at firstupdatesnow.com/FTC Reveal 2021 or at discord.gg/firstupdatesnow. All right, Lexi, we're going to be starting out on this robot with the intake and part of the hopper area. So let me know how that all functions, maybe some of the iterations you went through on this as well. Excited to see it.
Yeah. So this is something we just added recently, and it's for when the donuts are stacked. It pushes them out of the way so it easily can only get one. And then we have 2 large rollers and 7 smaller rollers that help the donuts go up and into our hopper. They have these orange tubings on them that helps them grab and push up the intake.
So can you show me how that ring enters, if you don't mind just putting it through? Are you actually driving over the rings? I see. Okay. So looking at this, what made you choose the type of design to actually drive over? We don't actually see that very common in FTC. FRC, I think it's a little bit more common to see, but you're probably one of the few teams I've actually seen that has this type of intake.
We discussed having the donuts or the rings come in the back and up the front, or like a claw to kind of bring them into our hopper. But we found this to be the best design for our robot.
Sure, fair enough. And as you're looking at the hopper, can you tell me a little about how that transfer takes place from the intake into the hopper and getting ready to go in the shooter?
Yeah, so we have this piece right here that stops it from overshooting. And then this just to keep it out of the way of the shooter, because we get this shooter revved up pretty early.
So looking at from an intake perspective, you have quite a ways to go, and there's quite a few rollers that bring that up and in. Have you had to do anything to try to mitigate like any of the rings jamming or anything like that at all?
Yeah, we first started with tape around our rollers because we thought that would give it enough grip, and we found out that it did not have enough grip to get up the whole way through. So then we added these little orange tubes. We also have some space back here. We originally had this aluminum piece bolted to this piece, and we found that it was too squished together, so the donuts would jam. So we had to put in little 1/2-inch tubing to get it more space.
Makes a lot of sense. Thomas, I know you're going to be talking about the shooter and essentially the transfer from the hopper into the shooter. So I'd love to hear more about the flywheel you have on there, any motors that are being used, anything like that on your robot.
Sure thing. So do you want to drive it here? We got a couple different parts going on here. After they get transferred from the intake into the hopper, we then have the shooter. Weighs about 1 pound. It's made out of aluminum. We custom machined it using a lathe. Our shooter also can tilt up and down to be able to face the goal from different positions. Lexi, do you want to tilt the shooter up? And over on this side of things, let's see here. We've got this limit switch down here, so that our shooter will always be at the same height for the driver. So the driver just pushes one button, and the shooter will automatically go up and tilt to face the goal. But when we're shooting farther back, we can also shoot a little bit lower, so we kind of loft them in there.
Yeah, that's what I was going to ask is from that angle wise, do you have a few different presets for that necessarily, or do you always typically shoot from the same spot? What's some of the strategy behind that?
Sure. So we've got a couple different settings going on here. The one touch sensor is designed for our main point of shooting, where we do consistently during our online matches where we can always shoot from the same spot. But we've also got a couple like physical hardware changes. So it's really easy to be able to see the distance between the physical part of the robot and the actual tilting hopper. So our operators who run the tilting and the shooting, they can kind of see the distance there to be able to judge how to shoot the power shots correctly. And if we're back a little bit farther, to angle the shooter down just a little bit.
Can we hold it right there and actually see a couple rings shooting out? Just love to see a nice close shot of that, how that works.
All right. You want to rev up the shooter wheel? Go ahead and fire them.
Wow, there's a lot of velocity of those. Do you know, maybe to get a little bit more in the nitty gritty of this, do you know like what RPM you're spinning that at? Maybe what compression you're putting on the rings or anything like that at all?
Yep. So it's spinning at about 6,000 RPM. And one of the struggles we had was the speed of the shooter. We could shoot them out quickly, but the main problem is they quite often be not very accurate. So one of the things we did to solve that is these bolts back here. You can see these. They're on the other side of the acrylic, and they're adjustable, so you can slide the acrylic in and out.
Sure.
And you can put different amounts of compression on it at each individual point. We've got 4 bolts total, allowing it to really mess with that arc angle, and we did a lot of testing to make sure that the donuts were really consistent.
How about the flywheel? You said you did that out on a lathe. How did you determine the right like weight in regards to is that motor actually being direct driven on there?
Yep, it is a direct drive. There's a bearing in the top here in this top plate, bearing in the bottom, and then there's the direct drive to the motor. Originally we had a much heavier 2-pound flywheel on here, but there are a couple problems. One, it took a very long time to speed up, and
yeah.
2, it had so much velocity that it really didn't slow down very quickly either. So we switched to this. This also helped get us in the weight limit because the whole robot's 41 pounds and 14 ounces.
Oh, wow.
So right up to the weight limit, we really were looking for places to cut. After we cut the little pockets out, all these pockets used to be filled. Once we cut those out, it lost us a lot of weight, and we found the shooter was actually more consistent.
Yeah, that's really cool, and I just love how efficient all that all those processes seem with all the handoffs as well. And you mentioned weight. I know we're going to be talking about your Waterjetted Base in a little bit as well too. But before we do that, let's head back over to Lexi, who's going to be showcasing the Wobble Mechanism, how that works. I know you guys got a really simple but effective design, so I always love showing off designs that just work well.
Yeah, so our Wobble has a pretty wide opening so that we have a lot of area for error to be able to grab the Wobblegles, and then it sits in a small pocket here, and when you bring it up, it's small enough so that it'll just stay on its own.
And that just holds in pretty well. Like if you were to shake the robot a little bit, would that actually still hold in?
Yep. Yeah.
Very cool. Like I said, very efficient design on it. I don't think there's really much more to be said about that other than it just seems like it works quite well on that. And I'm going to assume that's just like a polycarbonate, that sort of thing. What is that material made out of?
Yep, it's just polycarbonate, and then we just have 2 servos running it.
Well, very efficient with that, no doubt. So let's keep moving on. Thomas, I know you're going to be covering, kind of wrapping us up here with the ring blockers that you've added to your robot, and then also your custom water-jetted base as well, too. I always love to hear about custom chassis.
Sure thing. So at the beginning of the match, to fit in the cube requirement, Lexi, you want to tilt up the shooter real quick? We found those donuts really come out of there in all sorts of different directions. So we wanted to make our robot wider, and I know a lot of teams have done this, but what we decided to do to keep under the weight and to try not to add any more motors or servos, we just use zip tie arms that are Velcroed to the actual shooter plate. So as soon as we tilt down our shooter after the match starts, both of them will deploy out. And then they're pretty flimsy, but it really doesn't take much to tip those donuts over. And they also don't matter if they get run into at all because they're just zip ties. Yeah,
I love just a general concept. I think it's cool. A lot of our teams have been putting like a servo on it or something like that. But I mean, I guess the point stands, especially if you're doing remote challenges, you don't really need to worry about bringing them up or anything like that, right?
Not at all.
So very cool. And tell me about this water-jetted base that you have. I mean, you said your robot weighs 40 plus pounds. It looks like a decent amount of that is coming into the base, despite all the speed holes that you've created for it.
So we really drilled a lot of holes in here, but this whole base plate is completely custom water jetted. We catted it up and then took it to a West Tool and Design, which is a machining facility in our town, and worked with them to cut these pockets out for the wheels. They've got support on both sides, and then we've also got these aluminum plates over here that were bolted into the base. They got 4 bolts right here, tapped and threaded, and then it's very rigid, very sturdy base, so it can really take a beating.
No, love it. Thank you so much for showing off your robot, these different aspects as well, too. And once again, we're here at 15959 Central Lakes Robotics. Really wish you best of luck in the rest of this season and in future seasons. Can't wait to keep seeing what your team generates. Thanks for taking the time.
Yeah, thanks for having us on.
Thank you.
We would like to thank our friends at Stryker for supporting this video. Stryker is looking for current and future FIRST alumni to join their internship program, and FIRST mentors who are looking for a great career with a company who actually supports their FIRST journey. Go to careers.stryker.com to learn more. You can also directly support Fun by joining Fun Nation. Click the join button, and just for a few bucks a month, you'll unlock special perks and directly support us so we can keep making great content. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow. And check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.